Okay, guys, so for this next video, we're going to talk about section 5.3, dividing polynomials and using synthetic division. So basically, we're going to learn how to review a little bit of dividing polynomials, then do long division, and then do synthetic division. So the first thing let's talk about is dividing a polynomial by a monomial. So once again, you guys know when they're talking about polynomials, they mean like ax, something like this squared plus bx plus c, equals some f of x. That's a polynomial, but it could be x cubed, x to the fourth, x to the fifth. So we could have, 7x to the fifth plus 2x squared minus 3x plus 1 equals some h of x. So remember, a polynomial has has whole numbers in its exponents of the variable terms. So that's all they're saying when they say a polynomial divided by a monomial. So this would be some polynomial, and a monomial just means single term. Remember, poly means many terms and monomial means single term. So the way I like to do dividing by monomials is I just do this. I divide each piece as 3 separate problems, okay? So I'm going to end up with negative 12 over 3, negative 12a cubed over 3a plus 36a over 3a minus 15 over 3a. So that's how I do the work from when I'm dividing by a monomial. And again, we notice that this is a single term, which makes it a monomial. So this is a polynomial, and this is a monomial. And technically, a monomial is also a polynomial. Think of polynomials as like the umbrella that all of these things are. We have monomials, binomials, trinomials, so on and so on and so on. So we're just going to do the division. So I see that this divides this, and I'm left with 2. This becomes a 1, and this becomes a 4. This becomes a 1. This becomes a 12. The a's cancel. They completely become 1s. And then the 15 and the 3 cancel. This becomes a 1, and this becomes a 5. So let's rewrite what we have left. So we have negative 4a squared plus, now this will be 12 minus 5 over a. So that's pretty much the best we can do. Let me make sure that I'm answering it how the homework's going to want you to answer it. Yeah, negative 4a squared plus 12 minus 5 over a. And this would be our solution. This is what happens when you take negative 12a cubed plus 36a minus 15 and you divide it by 3a, okay? So let me have you guys try this one. So why don't you pause the video and do it just like I showed you and see what you get for your final answer. All right, so hopefully you've unpaused the video and you kind of split it like I did. You do these 3 separate little mini problems like this, and you should be left with 16x to the 6th over 4x squared plus 20x cubed over 4x squared minus 12x over 4x squared. Okay, let's see what we get. So this will become 4 and this will become 1. Now all the x's will cancel in the denominator and become 1, but this will become x to the 4th. The 4 becomes a 1, the 20 becomes a 5. All of these will cancel, become 1, but there'll still be 1 x left over in the numerator. This 4 becomes a 1, this becomes a 3, this becomes a 1, and this becomes a power of 1. So let's see what we have. We should have 4x to the 4th plus 5x and then minus 3 over x, looks like. Looks good. Okay, so once again, not too bad, right? So hopefully you guys got that from pausing the video. So now let's kind of go on to something slightly harder. Now notice it's still a monomial, but it has an x and a y. So I'm still going to divide just like this, same as I've been doing. So take a minute, pause the video, see what you get. Okay, so hopefully you guys have unpaused and you have 15x to the 4th over y to the 4th divided by 5xy minus 10xy divided by 5xy plus y divided by 5xy. So again, it's like you're doing, 3 separate little problems, okay? So now let's do our canceling. This becomes 1, this becomes 3. Okay, this becomes 3 x's left, this becomes 1, this becomes 1, this becomes 3 y's left. This becomes 2, this becomes 1. These cancel, all become 1. This y and this y cancel, and oops. So then we'll be left with 3 x cubed y cubed minus 2 plus 1 over 5x. Should be right. Yep, and this would be our final answer. So hopefully you guys are getting the hang of dividing by a monomial. Once again, all I do is I split it. I split it as 3 separate problems. That's what this is trying to tell you way up here. Once again, is you're allowed to split each one of these terms and divide it by the denominator. Because in fact, that's what the denominator is saying. Is it saying a plus b divided by c? It's not saying a divided by c and not b. It's saying a is going to be divided by c and b is going to be divided by c. Okay, so that's what they're just showing you, is that you're allowed to split it like that. Okay, so let's come back up here. Now, dividing polynomials, to divide a polynomial by a polynomial other than a monomial, we use a process known as long division. Polynomial long division is similar to number long division. So there's a pattern in long division techniques: divide, multiply, subtract, bring down, then repeat these steps until you can't bring down or divide any longer. So what I'm going to do is I'm going to kind of walk you guys through how I do it. I mean, it is basically like this, and then you repeat it. So this is why it's an algorithm. It's the same process repeated over and over again until you get to the final stage where you can no longer do it. So what I'm going to do is, we have this problem, 28x squared minus 23x minus 15 plus 7, or divided by 7x plus 3. So we're going to use long division. So you remember in long division, if you had 15 divided by 2, you would take 15 and you would divide it by 2. And then you would say, okay, what does a 2 need to become a 1? Well, you can't do that. So what is 2 times what will become 15? Oh, you say 7, so you get 14. Remember, you multiply these two numbers together, then you subtract, and this becomes 1, and this is now our remainder. So nothing's really changed. We're going to do everything the same, but it just is worse. It's just a little bit uglier, okay? So now you ask yourself the question, what does 7x need to look exactly like x squared? Well, it needs a times 4x, right? So I'm going to put a 4x right here, and I'm going to multiply 4x times both of these. So this would become 28x squared, and then this would become plus 12x, right? When I do 4 times 3, okay? So the moment you draw the bar, remember you're supposed to subtract. Well, really subtracting just changes the sign. So I'm going to distribute the subtraction, and this is now going to become 28x squared minus 28x squared, that's 0. And negative 23x minus 12x would become negative 35x. And then we bring down the 15. Now we ask ourselves the question, what does 7x need to become negative 35x? Well, it needs a negative 5, right? So now I distribute the negative 5 times both of those. That'll become negative 35x. This will become minus 15. I draw the bar, change the sign. So now this is going to become plus, and this is going to become plus. And then this is 0, and this is 0. So we end up with our final answer is 4x minus 5. Now, how do we know we're right? With division, how do we know we're right? Well, this is the quotient, right? That's the quotient. So we should be able to take the divisor, which is 7x plus 3, and multiply it by 4x minus 5. And we should get the dividend, which is this guy right here. This 28x minus, or 28x squared minus 23x minus 15. So now I'm going to distribute, and let's see what we get. 28x squared plus 12x minus 35x minus 15. So this is 28x squared minus 23x minus 15. That is identical to the original dividend, okay? So this is like our check. You don't have to do this part over here. I'm just showing you that I know I'm right, okay? So our final answer is actually what's right here, 4x minus 5. When we divided, we got 4x minus 5, okay? So the division process is continued until the degree of the remainder polynomial is less than the degree of the divisor polynomial. Okay, so here's another way they might write it. They might write it as an actual division problem. And we're not going to split it because this is what it would have to look like. You'd have to do negative 6x over 2x plus 4 minus 8 over 2x, oops, plus 7. Sorry about that. Plus 7, 2x plus 7 plus 4x squared over 2x plus 7. That just doesn't look very good, and each one of these would require, like, you really can't do much with this besides cancel out the x's. I guess you could do long division on that. You really can't do much with this, and then you would do long division on this. So you don't want to do 3 separate problems with monomials or trinomials in your denominator. The other thing is you don't want things written out of order. With long division, it has to go from the biggest power to the smallest power. So always write in descending order. And what descending order just means is from biggest power to smallest power. So here we have it written in biggest power to smallest power, descending order. So now we ask ourselves the question, what does a 2x need to look just like a 4x squared? Or what do we need to multiply by? So I'm going to multiply by 2x. So now 2x times 2x is 4x squared plus 14x, right? When I do times that. But the moment I draw the bar, I change the sign. So now this cancels and this becomes what? Negative 20x, bring down the 8. And now we go back to asking ourselves the question, repeat the process again. What does a 2x need to look like a negative 20x? It needs a negative 10, oops, not negative 10x, it just needs a negative 10. Now we distribute the negative 10. This becomes negative 20x minus 70. Draw the bar, change the signs. So this cancels and this becomes 78, okay? So let me catch up in my notes real quick. I kind of jumped ahead a little bit. So now we end up with 78. So now our final answer, I'll write it over here, is 2x minus 10 plus, and then you take your remainder and you divide it by your divisor, 2x plus 7. So whenever your remainder has a power or a variable power or degree smaller than 2x plus 7, or I'm sorry, smaller than the what you're dividing by, the degree of the divisor, then you just divide them in the final little piece right here. So this is our remainder term, see here? But it's a better way to write it than saying remainder 78. We're writing it as an actual, using this as our polynomial and then this leftover rational expression. So our final answer is not actually, is not any longer a polynomial. And in fact, if we wanted to manipulate it, I'm sure we could turn it right back into a rational expression again. But this is going to be our final answer. And that's what we would be okay with. So when you actually do the division, you end up with 2x minus 10 plus 78 over 2x plus 7. Okay. So why don't you guys pause the video real quick and try this one, see if anything bad happens. Okay, so hopefully you notice that here they have 0 x's, and that's because x cubed minus 8 has missing terms. It should be something like x cubed plus, x squared plus x minus 8 or something like that, but these terms are missing. So the only way we can account for them is by using placeholders. So we're going to put a placeholder here for the x squared term, and we're going to put a placeholder here for the x term. So what we're going to do is we're going to do the same thing that we did before. We're going to ask ourselves the question, what does x need to look just like x cubed? We need an x squared, okay? So now we're going to say that this is x cubed minus 2x squared. I draw the bar, change the signs, okay? So now this goes away, but now I have a 2x squared added to 0x squared. So this prevents me from making a mistake and adding it to somewhere else. Bring down the help. But that's not going to help too much, but oh well, we'll just go with it and see what happens. So now we ask ourselves the question, what does the x need to become a 2x squared? Well, it needs a plus 2x, right? So this will become 2x squared minus 4x, right? But the moment we draw the bar, once again, we change the signs. Gone, and this becomes 4x, bring this guy down, minus 8. Okay, so now we ask ourselves the question, and again, you see how the algorithm just keeps kind of repeating itself. It's a little monotonous. Well, that's kind of the point of the algorithm. Okay, it just keeps repeating itself. We do the same thing over and over again until we get to the desired result. Our desired result is our remainder to have a smaller degree than our divisor. So we're going to do it one more time. We're going to say this needs a plus 4. So this will be 4x minus 8. Draw the bar, change the sign. This becomes minus, this becomes plus. We get 0 and we get 0. Okay, so no remainder this time. So then our final answer is x squared plus 2x plus 4. And that is our quotient. That is our final answer. Okay, when you divide those two things. So now, hopefully you guys kind of got a hang of that with some placeholders. Now let's look at synthetic division. So to find the quotient and remainder when a polynomial of degree 1 or higher is divided by x minus c, a shortened version of long division called synthetic division may be used. So for our class, we're only going to use synthetic division in very specific cases. In general, we're going to try to stick to when there's a 1 in front and then when the term is x to the first power. Okay, so that's kind of how we're going to use synthetic division for our class, and I'll show you the steps. Okay, so the book has this really long representation of it. What I would say you do every single time is you take, let me see here. We are dividing x plus 1, so in the form x minus c. Okay, so hold on. Here we go. I lost the problem. So here's the problem we're going to work with, okay? So instead of doing long division, what we're going to do is we're only going to write the coefficients in front of the x terms, okay? So it's a 1, it's a 3, and a -2. So that's why you see a 1, a 3, and a -2. And then you put this little box right here, okay? And then this number here, this -1, this comes from solving x plus 1. We do x plus 1 and we set it equal to 0. And then we subtract 1, so we get x equals -1. This is what we're dividing, or this is what we're dividing out. This is what we're using for our synthetic division. So what we're going to do is we're going to put a -1 right here, okay? So now what I always do is I now just draw a bar, and you always bring the first term down right away. So we get a 1 there, okay? Now, different than long division, you do addition, okay? So you multiply -1 times 1, and that'll give me -1. You put it right there. And then you add, so this will give me 2, okay? So now we do -1 times 2, okay? -1 times 2 is -2, right? Let me double check something real quick. Let me just make sure. Okay, so now we get -4. Okay, so what this means is we're now done, right? This, the final term, is my remainder. That is my remainder, okay? So if I want to convert this back from synthetic division and back into, to look like our answer as a polynomial or something similar to a polynomial, rational expression, what we're going to do is we're going to reduce the power. So this is, remember, we started off with an x squared, and we had an x to the first, and then we had a no x, but we divided by an x to the first. So now think about this. If I took x cubed and I divided by an x squared, I would get an x power left, right? If I took an x to the fifth and I divided by an x squared, I would get an x cubed. Okay, so our power is always reducing by whatever the divisor's numerator, I'm sorry, the divisor's degree was. So in this case, the divisor has a degree of 1 and the dividend has a degree of 2. So that means our final answer should have a degree of 1. So then what I do is I put a little x here, right? That's x to the 1, and this is x to the 0, and then this is the remainder. So here's how we're going to write it. X plus 2, x plus 2, because x to the 0 is really 1, minus 4 over x plus 1. So I wrote, just like here's the divisor, x plus 1, and here's my remainder, and I wrote it as -4 over x plus 1. Okay, so we got to practice this quite a bit. Let's look at another one. Okay. So here, let me have you guys pause the video. Try to write this out, how you think synthetic division would work on this particular problem. Okay, so hopefully you unpause the video and you have something that looks like this. 3 minus 2, 5, and 4. Remember, you have to account for each degree, each change in power, okay? And then you're going to be divided by, now, x minus 2, if you solve that for x, you'll get positive 2 as what you're checking for. Basically, this is a way you can also check for zeros, but there's faster ways to do it than this. Then I draw my little bar right here. Okay, so now we always bring the 3 down. So we have 3, right? And then 2 times 3 is 6. That becomes 4. 2 times 4 is 8. That becomes, what do we get? 13. Okay, oops. Yeah, 13. And then 2 times 13 is 26. So this becomes 30. Okay, let me just make sure. Not making any silly mistakes. Okay, so we have that. So now remember, the power started off as an x cubed, and we divided by an x to the 1. So our final answer should be in terms of x squared, x, and then no x's, right? And then here's our remainder, okay? So we're going to end up with 3x squared plus 4x plus 13 minus 30 over x minus 2. And that would be the division, okay? So 3x squared plus 4x plus 13. Oops, I think it's supposed to be plus 30. I don't know. I think this little line right there threw me off. Yeah, it's supposed to be plus 30. Okay, so that'll be our final answer for that. Now we could do long division on this problem just as well. We could also do long division and get the same answer. So long division and synthetic division will give you the same answer. It's just depending on which problem you're working on or what's being asked of you. To me, long division is like fail safe. Long division, you know, it takes longer, but it's tried and true. There's not a lot of hiccups that can happen. Synthetic division is much faster, but there's some, you know, interpretation you have to do with the degrees. If you're ever dividing by an x squared term, you got to be more careful. You know, there's other things you have to worry about with synthetic. With long division, it's just longer and slower, but it's very straightforward. Synthetic requires a little bit of, I don't want to say skill. How do I say this? A little bit of technique, I guess, and it's not as, you know, straightforward as long division. Okay. So let's try one more with synthetic. You guys pause the video and give this one a shot. Okay, so the reason I wanted to do this last one is because this one is missing the x squared term. So with synthetic division, every single term of every degree must be accounted for in some way. So we're going to say 1 for the x to the 4th term. We're going to say 3 for the x cubed term. How many x squareds are there? There are 0 of them, minus 5 for the x term, and then 4 for the no x term. And then we're going to divide it by -1. Okay. So we bring down the first number 1, and then we multiply. -1 times 1 is -1. This is 2, right? Now -1 times, so remember, I'm multiplying. -1 times 2 will give me this number here, which will be -2. This is -2. Then -1 times -2 gives me +2. So this becomes -3. So hopefully you guys are seeing how I'm doing this. -1 times 3 gives me +3, and this ends up with a 7. Okay. So now when we write our answer, remember we started off as an x to the 4th, but we divided by an x to the 1st. So we should end up as our final answer with x cubed plus 2x squared minus 2x minus 3 plus 7 over x plus 1. And that is how you use synthetic division. Much faster than long division, but you got to be more careful. You still use placeholders, but if you, in long division, you can get away without using placeholders if you just make sure you don't accidentally add things incorrectly. But with synthetic, you really need the placeholder there, like you must have it. Okay, so hopefully you guys see that. So something hopefully you noticed is whenever there's a remainder, that means that this term, this divisor, does not divide evenly. So that means it's not a factor. Here, once again, x minus 2 is not a factor. However, here, oh no, this one also, x plus 1 is not a factor. But in this problem, you see how we got 0 as our remainder? That means that x minus 2, you could take x minus 3. Oops, I'm sorry. You could take, let me do it as scratch work. You could take x cubed minus 8 and you could divide it by x minus 2 and you would actually get it to work correctly. It is a factor of x cubed minus 8. And here's how you could know. This is actually factorable to x minus 2 using the difference of cubes, and this would be x squared plus, what would that be? 2x plus 4 divided by x minus 2. So I just used the difference of cubes to factor that. So this cancels with this. So it is in fact a factor, and look what I have left behind. And what a factor means is it's one of the things that you could build something through multiplication, but you can also use division to check it, okay? So we do know, in fact, this is a factor of x cubed minus 8, but so is this. This is also a factor. And this was all told to me because I got a remainder of 0. When you get a remainder of 0, that means it is a factor. That means it is a 0 of the polynomial. When you don't get a remainder of 0, that means it is not a 0, and that means that it is not a factor of that polynomial. So now let's come over to here. It says if p of x is equal to this polynomial, x cubed minus 5x minus 2, find p of 2 by substitution, and then use synthetic division to find the remainder when p of x is divided by negative 2. So what we're going to do is we're trying to show you something here, okay? So if I take p of 2, I do p of 2, and that means I do 2 cubed minus 5 times 2 minus 2. So this will be 8 minus 10 minus 2, so this will be negative 4, right? So we get negative 4. Okay, so now over here, what they want us to do is they want us to use synthetic division using x minus 2. So we know that we're going to do 1x cubed, 0x squareds, minus 5x, minus 2, and we're going to divide by positive 2, right? Because x minus 2 equals to 0 means that x equals positive 2. So now we draw our bar. We do this. We bring this 1 down. We get 2. This is 2. This is 4. We get negative 1. We multiply again, we get 2, and we get 0. So remember, what does this 0 signify? It signifies it's a factor, but that is the remainder of, oops, hold on. I think I messed up. Yep, I'm sorry, hold on. So 2 times negative 1 should be negative 2, so I should get negative 4, okay? So notice here, this remainder is negative 4. When I plug in p of 2, I get negative 4. So you can quickly find the remainder of something by plugging a value into the polynomial. When you plug that value into the polynomial, that would be the remainder you would get is if you did the division using synthetic or long division of its factor, okay? So says if a polynomial p of x is divided by x minus c, then the remainder is p of c. So this is the remainder theorem. There's something else also called the factor theorem that says that if the remainder is 0, then it is in fact also a factor, okay? So if p of c equals 0, then that means x minus c is a factor. That's the factor theorem, but they don't say it here. We're not going to go too crazy on that, but the factor theorem is normally combined with the remainder theorem, okay? So it says use the remainder theorem and synthetic division to find p of 3. So I could just say, well, p of 3 equals, and then I could just do 2 times 3 to the 5th minus 18 times 3 to the 4th plus 90 times 3 squared plus 59 times 3. So this is definitely a calculator question. So let's put this in our calculator. Okay, I'm just plugging it in right now. So I get 15 as my value. Okay. So what this is telling me is that if I get 15 when I do P of 3, that if I do synthetic division, I will also get 15 as the remainder. So let's see if it works. Let's see if the remainder theorem is correct in telling us that. So I'm just going to do synthetic. So here's my 3 right here. And then I'm going to do 2 minus 18, 0, 90, 59. and then 0, okay? So let's see what we get. We get 2, we get 6, that's negative 12, that's negative 36. That would be negative 36. So let me do negative 36. Negative 36 times 3, we get negative 108. This becomes what? Negative 18. Negative 18 times 3 was at 54. Negative 54, that becomes 5. Negative 5 times 3 is 15. That becomes 15. So we have a remainder of 15, just like we thought. So that means that this is not a factor. X minus 3 is not a factor because the remainder is not 0, okay? So, and again, the answer, the final answer would be 2x to the fourth minus 12x cubed minus 36x squared minus 18x plus 5 plus 15 over x minus 3. That's what it would look like as a polynomial, but they just wanted us to find the remainder. So this is correct and this is correct. I just wanted to verify that the remainder theorem was telling me the truth. And again, theorems in general tell the truth. That's kind of why they're there. Okay, so hopefully this helps you guys get started. But here's the video for chapter 5.3. Okay. All right, let's go back up to the top. 5.3, dividing polynomials using synthetic and long division. All right, you guys, I'm going to end the video. Thanks for watching.